Well, welcome back everyone. I feel a bit like the mad professor today. I've got to slip out and get a bit of a haircut today, but I just wanted to continue this series on the superheterodyne receiver. Today we're going to take a look at the detector and AGC stage, almost to the end. One more following this, and that will be the audio stage. So let's have a look at it. So in this video, before we actually talk about the demodulator, I thought it best that we actually talk a little bit about what amplitude modulation actually is. So this is just going to be a simple explanation. It does get a lot more complicated than this, but this should suffice for what we need. So let's consider we have an audio signal. So it could be the microphone, it could be music or something like that at a radio station. And what we want to do is modulate a carrier wave. So the carrier wave is simply going to be a sine wave at the frequency that the radio station operates at. So if the radio station is 100 kilohertz on the dial, then that carrier wave frequency will be 100 kilohertz. So we've got an audio signal here, which is, down around the 100 to 10k hertz, and we need to somehow get that applied, or that information applied, to the carrier signal. And what we actually do is simply control the amplitude of that carrier wave using the audio signal, which is effectively just adding the amplitude of the signals together. So you'll see in that third waveform that the amplitude of the actual carrier frequency is just limited by the actual audio signal. So that's what actually gets transmitted from the actual radio station's aerial, and that's the exact signal that we pick up at the aerial of our radio receiver, albeit very, very low level. So how can we actually recover that initial audio signal from that particular signal there? Now, we've already talked about the RF stage, the mixing stage, and the IF stage. The good thing about the superheterodyne receiver or technique is that RF signal with this modulated waveform on it, when it passes through the mixer, the IF signal will, that is at 455 kilocycles, also still has that particular amplitude modulated signal on it. So out of the IF amplifier, we are getting a 455 kilohertz signal that's amplitude modulated in that same manner. This is what it looks like. So to recover that signal, first of all, we just half-wave rectify it. So, and you'll note that once it's half-wave rectified, if we were to smooth out the peaks of that particular waveform, we'd actually have that original waveform back again. And look, it's as simple as that. That is exactly what we do. We smooth it with a RC network, a capacitor and a resistor, and recover that original audio signal off the IF frequency. So in simple terms, that's all there is to AM modulation and demodulation. So let's take a look at the circuits now and see how it is in practice. Okay, so now let's take a look at a valve circuit. So here we can see the actual receiver circuit right from the antenna connection here through to the actual demodulator valve here. In the middle we have the frequency changer or the mixer and combined local oscillator. And you'll note there's ganged capacitors here, just like we've seen previously. There's quite a lot of switching and things around in this particular circuit that we don't really need to concern ourselves with. It's for switching between broadcast band and shortwave, so different tuned circuits are switched in place for the oscillator and the RF filter. And in this case, we're actually using a single valve for the oscillator and the mixer. We've got our first IF filter here, we've got a single stage IF amplifier, and on the output of that IF amplifier we have another tuned circuit, which is where we left things in the last video. And following on from that, this transformer couples the IF signal through onto V3, which is our demodulator valve. Now in this radio, this valve actually forms dual function. It forms the function of the demodulator and also the first audio frequency amplifier. So at this point in time we're just going to look at the demodulator section of it, and you'll note that the signal from that tuned circuit is actually applied to pin 6 on that valve, which looks like an anode. Now this valve is actually a 3-element valve. It has a triode section in it, and it actually has 2 diode sections in it. And for the demodulator, we're just using one of the diode sections. So in this circuit, the diode section of the valve is half-wave rectifying the signal from the transformer, and C16's filtering it to create the audio. So you'll see the signal that we have across C16, which is essentially the audio, goes through R4 here and is further filtered by C16, and this actually forms the AGC signal, or the automatic gain signal. And that signal is fed through the tuned circuit to the grid of the IF amplifier, and also through another resistor here, and these switched tuned circuits onto another grid in V1, the frequency changer. Now that filtered signal there is actually used to control the gain, so it affects the bias of the IF amplifier and the frequency changer, or the gain of the frequency changer. So when we get a strong radio station, the amplitude is reduced somewhat, and when we get weak ones, the amplitude is raised, so that it tries to even out the way the radio receiver, or the gain of the radio receiver, depending on the actual radio stations. In the evening we can sometimes have radio stations fading in and out, and it also works to try and reduce the amount of change there is in the audio signal. One other thing we'll touch on here, if you look at R8 and C17, you'll see that that signal is also further filtered and appears across VR1. So VR1 is the actual volume control for the radio. So on the wiper of VR1, we can consider that to be the audio signal that we're going to now amplify and feed to the speakers. Okay, so now let's have a look at the transistor equivalent. And again, I've done a similar thing here in that I've shown the total circuit up to the actual detector stage. So we have the RF amplifier, mixer and local oscillator section, which is here. We have that first IF filter here, the IF amplifier, another filter here in the center, the second stage IF amplifier, and the output of that IF amplifier is again coupled through this transformer to this winding. And here we have the actual demodulator diode D2. So again, it's exactly the same principle. This diode and capacitor is effectively half-wave rectifying the IF signal and filtering it to turn it back into an audio signal. And just as before, if we take a look at this connection here, it's actually labeled automatic gain control. That's fed back to the base of this first transistor, again with some additional filtering of the signal to control the bias point of the actual IF amplifier and thus the gain. And just as in the valve circuit, if we take a look at this variable resistor here, this is actually the volume control for this particular circuit as well. So again, this particular point here, we consider that to be the recovered audio signal. Okay, well that's it for the demodulators and AGC stage. Next we'll be looking at the audio stages of the valve and the transistor circuits. If you enjoy this video, then please like it. If you've got any comments, then please add comments and I will endeavour to get back to you. If you'd like to see more of what I'm doing, then please subscribe and hit the little bell indicator so that you see new things that I do. And you can also check out my Facebook and my website for more information. Okay, thank you.